Hello, this is another video on counting, and I will explain how that works. Now in this video here, in this problem here, we have to jump by 2. So unlike the previous problems where we have to sequentially go up by 1, here it says count by 2s starting at 8. So one way you can think about this is we have 8, which is our starting point. Then we're going to skip the next problem. Then we're going to go to 10. We're going to skip the next. Hello, this is another video on counting. In this problem here, we're going to count by 2s, whereas in the previous problems that we did, we were counting by 1s. So one way you can think about this is that we start at 8. Here we go, 8. We're going to skip the next number. We're going to go to 10. We're going to skip the next number. We're going to go to 12. We're going to skip the next number. Then we're going to go to 14. So that's what they mean by count by 2 starting at 8. Starting at 8, 1, 2. 1, 2. 1, 2. So what they're looking for in these boxes are 8, and then we got 10, 12, and 14. So here they're asking us to count by 5s starting at 7. So we have 7. So instead of doing 1, 2, 3, 4, 5, now let's do something else. Let's try this. So we have 7, and we have to count by 5s. We have to go forward 5 or add 5. Well, 7 and 5 is 12. You can use your fingers to count if you need to. So that's one jump. So that's 12. Let's put that in there. Okay. Well, how do we move forward from here? Well, how about we add another 5 to the 12? It's the same number of steps each time, 5. So 2 plus 5 is 7. 1 plus 0 is still 1. So the second answer should be 17. And then finally, let's add 5 to the 17. And what will that give us? 7 and 5 is 12. Carry the 1. We'll add it next. 1 and 1 is 2. 22. So 22 is our last jump. So we're skipping, counting by 5s. We're skipping in between numbers, and we're landing on each 5th one. Okay, so here we're counting by 10s, and we're starting at 14. So we have 14. We're going to skip forward 10. That's one answer. We're going to skip forward another 10. It's another answer. We're going to skip forward another 10. There's another answer. So let's put that in there. 24, 34, 44. Count by 100s, starting at 160. Well, we're not going to use that diagram. It's almost impossible to use it anyway, right? So small. We're going to add, just like we just did. Same, very similar concept. So our starting point is 160, and we're counting by 100s. We're moving forward, we're skipping forward by 100s. 0, 6, 2. It's our first answer. We're going to skip forward another 100. 0 plus 0 is 0. 6 plus 0 is 6. 2 plus 1 is 3. Our second answer. Then we're going to move forward 100. Excuse me. 100. So 0 plus 0 is 0. 6 plus 0 is 6. 3 plus 1 is 4. This should be our third answer. So let's put those in there and see what happens. So we have 260, 360, 460, okay, next question says, complete the pattern. So we have a pattern going on. We have a pattern. So we have, let's write these down. 23, 25, 27, 29, blank, 33. So where can we detect the pattern? Well, we need to fill this in. So we can't just look to the immediate left and right. We could actually, but to become more certain of the pattern, let's start from the beginning, from the left-hand side. So we have 23, 25, 27, 29. Is there any particular kind of sequence that you notice? Are we going up by 1s, 2s, 3s, 4s? Well, the difference between 25 and 23 is 2. The difference between 27 and 25 is 2. The difference between 29 and 27 is 2, just by subtracting. So there's always a difference of 2. So you can make the assumption that 23 plus 2 is 25, plus 2 is 27, plus 2 is 29, 29 plus 2 is 31. And if we look at our next number in line, 31 plus 2 is 33. So yes, 31 is correct, because a difference of 2's is what's the same for all of these numbers. Okay, so let's try 31. So the pattern skips numbers by 2, we said. Complete the pattern. Write the number that completes the pattern. So let's try this one. So we have 17, blank, 27, 32, 37, 42. In this case, the unknown is near the beginning, so we have to look at the last 4 numbers to detect the pattern. So let's do the same kind of procedure. What is the difference between 32 and 27? The difference is 5, right? That's how much space there is between those numbers. How about between 32 and 37? What is the difference there? Well, that's 5, okay? How about the difference between 37 and 42? And if you were to subtract those, you also get 5. So 5 seems to be how much we're skipping by. Knowing that, let's go back to the beginning from 17. So what do we have to do to 17? Now these numbers are going upward. See that? They're getting bigger. So we have to add 5. We have to add 5 to 17. Okay, we have to add 5 to 17. 17 plus 5 gives us 22. Now, if we add 5 to 22, are we going to get 27? Yes, we will. And so on and so on. So we're skipping by 5, and the missing number we're looking for is 22. And pattern skips numbers by 5. Okay, we have the same type of problem, bigger numbers. That's okay, we can handle bigger numbers. Same pattern techniques. So what do we got? 748, 758, blank, 778, 788, 798. Okay, well, let's look. This is kind of in the middle, isn't it? This missing term is kind of in the middle, but there are more numbers down here. So let's look to see a pattern down here. We have 778, 788. What is the difference between these two? 10, right? 10 is the difference. If you were to subtract, there's a difference of 10 between those two. All right, well, how about this? What is the difference between 798 and 788? The difference is also 10. So 10 seems to be a possibility. Now, we can also do the same thing here. Let's find out what the difference is between these numbers. 758, 748. The difference is also 10. So we can be pretty certain that 10 is what we're skipping by. 748 plus 10 is 758. 758 plus 10 is 768. 768 plus 10 is 778, and so on. So it looks like 768 is what they're looking for in this pattern. And the pattern skips by 10. Okay, for this problem, bigger numbers, but same technique. 120, 220, 320, 420, 520, blank. Now, one thing you can kind of notice here, and when you say these numbers, it's more apparent. They all end in 20, right? 20, 20, 20, 20, 20. What changes is the hundreds spot number. This is the ones, the tens, the hundreds. So the hundreds goes from 1, 2, 3, 4, 5, and we can only guess it's going to be 6. And what goes here? They're all 20s, so it's 20. So that's one way you could have done it. The other way you can look at it is that it's a difference of 100 between all of these numbers, right? There's a difference of 100. So you have to assume then that there's also a difference between 520 and 620 of 100. So let's put 620 in there and see if that's what they're looking for. So now we're skipping by 100. Okay, so now we're changing gears a little bit. Now they want us to know which of the following numbers are divisible by 2. When something is divisible by something else, what that means is that there's no remainder. It means the number goes into that other number evenly with no remainder, zero remainder. So that's one way to think about it. So if we divided 2 into each of these numbers, the result that gives us a zero remainder means that it's divisible by 2. If we get a remainder when we divide 2 into all of these, that means it is not divisible by 2 because we have a remainder other than 0. So that's one way to do it, but there's a shorter way to do it actually. And let's write that down here. So we have something what's called even and odd numbers. Even numbers end in 0, 2, 4, 6, 8. Odd numbers end in 1, 3, 5, 7, and 9. So these numbers are even when they end in these numbers, ending number, the rightmost digit, and the number is considered odd when the rightmost digit is any of these. So what does that have to do with this? Well, if a number is divisible by 2, it's going to be even. It's going to be even. So these numbers are divisible by 2. They are not. So all we got to do is look at the rightmost digit, which is the ones digit, to determine if that number is divisible by 2. Okay, so let's keep that there and let's scroll up a little bit. Let's see. Okay, right about there. So let's make a list. So let's call this even, odd. Let's go right down the line here. So let's look at the number 4. Is the 4 divisible by 2? Well, is it even? Yeah, there it is. So it's divisible by 2. So 4 is even, which is divisible by 2. 3. 3 is on that list. Nope. It's an odd number. It is not divisible by 2. 12. Does 12 end in a digit that's here? Yeah, it ends in 2, right? 12 ends in 2. So 12 is even and is divisible by 2. Then we got 5. 5 is not divisible by 2. Then we got 14. 14 ends in 4. It's on this side. So yes, 14 is even, divisible by 2. 18 ends in 8. Yes, divisible by 2. 9, nope. Then we have 6. There it is. It's divisible by 2. Then we have 20. It ends in 0. 20 ends in 0. Divisible by 2. We have 15, which ends in 5. Nope. It's odd. It's not divisible by 2. And then we have the number 10. 10 also ends in 0. So it is even. It's divisible by 2. So all of these right here are even, which means they are divisible by 2. All right, so let's put that in there, and the order shouldn't matter. 4, 12, 14, 18, 6, 20, 10. Okay, so we have one more question to do, or 2 more questions. This says determine whether the number is even, or odd? Well, I just erased that list, but 1 is an odd number. So let's see if we can pick the right choice here. The number 1 is even. Nope. Nope. It's an odd number. The number 1 is an odd number because it is not divisible by 2. That makes sense, but let's keep going and see why the others would not make sense. The number 1 is an even number. Nope, that's not it. Nope. And then finally, we have the number 1 is an odd number because it is divisible by 2. That makes no sense. The number 1 is odd because it is not divisible by 2. Okay, and then finally, number 11 here, determine whether the following number is even or odd. I really don't care how big it is. So, for example, let's say we have this number. Is this odd or even? I can care less about all these digits here. That's all I care about right there. It's 2, it's even. So it doesn't matter how big the number is. We're looking at the rightmost digit, the ones digit. So here we have 46, and 6 is even, which makes 46 even. The number 46 is an odd number. Nope, that's not it. The number 46 is an even number because the last digit is an odd number. That makes no sense. The number 46 is an even number because the last digit is an even number. That makes sense. And let's look at the last one just for fun. The number 46 is odd. No, it's not. It's even because 6 is even. Okay, so we're done this section, and that's how you perform counting when you jump between different numbers when the sequence isn't sequential. If you like my content, click the like button, post your comments, and subscribe to my channel. Thank you for watching.